Oh, hey guys. I wanted to give you guys some extra examples based off the stuff that we did last week on Friday, just to make sure that you guys were on point with these. One of the things that we're going to ask you to do tomorrow on the exam is to graph equations that are in what we call slope-intercept form, and then equations that are going to be in standard form. So this is slope-intercept form right here, slope intercept, and this right here is going to be standard form. The easiest one to work with right now as far as graphing is typically going to be your slope intercept, just because we are given our slope and then we are given our y-intercept. Now our y-intercept here is -2. Now remember, the y-intercept is the number that has no x attached to it. Okay, it's our sole constant, not our only constant term, but it's the term that's by itself. It's just one number. It's always -2, no matter what I plug in for x or y. So let's use blue. I'm going to use blue to graph it. So my y-intercept is -2. So I go to the origin, which is right here, and I go down 1, 2. At that point, I'm going to go ahead and then locate a point. Now my y-intercept right here, y-intercept, my slope is 1/3, meaning that I'm going to go down here to this y-intercept that I located. I'm going to go up 1 and then over 1, 2, 3. I went up 1, 1, 2, 3. Okay, let me get rid of that because I don't really want that there, but I went up 1, 1, 2, 3. And you could do that again if you wanted to. You could go again up 1, 1, 2, 3, and go ahead and locate another point. It doesn't really matter. After you have 2 points, you can go ahead and just draw the line straight through those points, and you're good to go. And this is the equation of y equals 1/3 x minus 2. For standard form, that usually takes a little bit more work, and I was asking you guys to do this last week, and we had a little bit of fun with it. 3x minus 2y equals -18. I'm writing this over off to one side, and then I'm making a small table. Now on this side, I'm going to go ahead and find what I call my x-intercept. On the right hand side, I'm going to find my y-intercept. For my x-intercept, I keep my x in my equation, just like I have right there, and it's -2 times, and I'm going to plug in 0 for y equals -18. What this does is, since I know that for my x-intercept, which is this axis, I know when my graph crosses this axis, no matter where I'm at, my y is always going to be 0, my y value. So this right here, you know what, let's do that in a different color. Let's do it right here. This whole thing right here is going to get crossed out. -2 times 0 is just 0. I'm left with 3x equals -18 divided by 3. X equals -9. So I cross the x-axis at, well, that is not true, at -6. So I can write this as -6, 0. Okay, that's my x-intercept. For my y-intercept, I do the exact same thing, except I'm going to plug in 0 for x. I'm going to minus 2y, and that's equal to -18. Now again, this right here is going to get crossed out because it's going to go away. It turns into 0. I just got to make sure I remember that I keep this little tiny negative right here. I make sure I keep that attached to the 2y. So I'm left with -2y equals -18 divided by -2. Y is equal to negative divided by a negative is going to be a positive. Y equals 9. I hope I gave myself enough space. I'm not sure. I didn't try this out beforehand. So my y-intercept is 0, -9. So the way I graph this now, this represents a point. From the origin, I'm going to go ahead I'm going to go ahead and go left 6. 1, 2, 3, 4, 5, 6. At that point, I will locate a point. That's the point -6, 0. For the y-intercept, again, this represents a point. It means 0 left or right from the origin, and I go up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. I hope I counted right. Which again, 1, 2, 3, 4, 5, 6, 7, 8, 9. Good. Now that I have my 2 points, that's all I needed. And now I just draw my line through those 2 points. And that represents the graph of this equation right here. It's a little curved. You guys will have rulers tomorrow to make sure that those are straight lines. Notice that I didn't just connect the 2 points. I drew a line with an arrow all the way through. So that's how you graph lines that are in slope-intercept, and that's how you graph lines that are in standard form. Okay, the other thing you're going to be expected to do is to find the equation of a linear function. Now, you could be given it as a table or as a graph. Let's do the graph because that's the easiest thing to do. This graph, really, all I'm looking at here is y equals mx plus b. Now, again, to remind you guys, m is slope, my rise and my run, and then here b is going to be my y-intercept, where I cross the y-axis. Let's do our y-intercept first. That's the easiest thing to handle. The y-intercept happens when this graph right here crosses this y-axis. I know I didn't label them. I'm sorry. We'll call that y. We'll call that x. Okay, I crossed the y-axis right here, so I'm going to go ahead and just locate that point. Okay, that's right. That right there is going to be 1, 2, 3, 4, 5. My b is equal to positive 5. My slope is a little bit trickier. Typically, we can use the y-intercept. As of right now, we're not going to give you anything funky like a fraction or you know, something that crosses right here or whatever. Whoops. We're not going to get that tricky. We're just going to keep it a little bit simple until we understand the concept, and then we're going to get a little bit more complicated. My slope. I'm going to go ahead and use this same point right here. Now, what I'm going to do is I'm going to look along the graph, and I'm going to see where this graph crosses one of these little intersections here. All these little intersections are nice points to look at. So if I travel along this graph, I keep going, I keep going, I keep going. I don't find one right there. Maybe I could go backwards. Let's see. You know what? I think this one right here is going to have to work for us. Okay. I always start with my left-hand point. And I know, oh gosh, I should have done this. I didn't put scales here. This is going to be -1. This will be -2. This will be +1, +2. I'm sorry. It's late. Trying to get this done. This is counting by ones here. So I'm going to draw a line up and I'm going to draw a line over. That represents my slope. My change in y is equal to 1 because I went 1 upwards, and then I went 2 over, which means my change in x is equal to 2. So my change in y over my change in x, that's my m, is equal to 1 over 2. Now all I have to do is compose the equation. I'm going to write it right here. Y equals, my slope is 1/2, 1 over 2, x plus my y-intercept, which is 5. Super easy. It's honestly easier to come up with the equation, well, sometimes, than it is to actually graph some of these ones that we've been graphing. So you have to be able to come up with the equation of a linear function from its graph. Now, the other thing you have to be able to do is come up with the equation from a table. Now, from a table, your guys' initial reaction is going to be to do this. And in this case, that's going to be correct. What we want to do is we want to find our rate of change first. Here, we're increasing by 2 every single time. That's good. Here, we're increasing by 7 every time. That is also good. It's a constant rate of change. I can tell because my change in y is 7 and my change in x is 2. Well, you know, this really lends itself to what m is supposed to be, because m is change in y over change in x, and I just have 7 over 2. Do not bother changing that into a decimal. If it is a whole number, go ahead and divide it, but if not, just leave it. It's fine. This thing is perfect as it is. like that. We're going to use that. The next thing we need to figure out is our b. Now the problem is b happens, b is going to happen, our y-intercept happens when x is 0. Problem is we don't have x0 here. So what we're going to do is we're going to go ahead and we're going to work our way backwards to get to 0, because I know when I increase by 2 here, this is increasing by 7. So I'm going to go ahead and go backwards 1. That's going to once. If I'm increasing by 2, I can go backwards in 2 and I can get 4. If this is increasing by 7, I can go backwards by 7. So this would be 0. Now some of you guys are going to want to stop right there and say your y-intercept is 4. That would be false. Your y-intercept isn't 4. Your x-intercept is 4 because y is 0. We need to keep continuing back with this until x is 0, not when y is 0. So I'm going to go back again one more time. That's going to put me at 2. I'm going to go back again here. That's going to give me -7. 0 minus 7 is -7. I'm decreasing by 7 here when I move up the table. Now I need to go one more time. If I go one more time, I'm going to hit it. I got x equals 0. Go backwards 7 again. That's -14. So my b is going to be -14. Now all I have to do is again put all these pieces together. You know what? Let's make that a little bit thicker so you guys can see it. Y equals my m. We have that. That's 7 over 2. Do not change that into a decimal. Leave it as it is. And my b is -14. I got that from the graph. That b happened when x was 0. I got y to be -14. Again, don't stop here because you got a 0 for y. You got to continue back until x is 0. Okay. What I would do, you guys, is you could probably come up with your own examples just from just make something up on your own. There's a really cool website. Let's see. It's called desmos.com. You guys can go ahead and plug in y equals 3x minus 4, and it gives you the graph of that equation. So if you guys want to come up with some equations that you then want to graph, you can do that. You can even put some in standard form. 3x minus 4y equals 12, and it'll graph it for you in standard form as well. The only thing it can't do is that you can't just come up with a graph and then you find the equation, but you can always get your little brother, your little sister, or older brother or older sister, or mom and dad to punch in some numbers for you, and then you take and close this down like this, and then you take a look at the graph and try to come up with the equation. In any case, hope this helps. Good luck, guys, with the studying, and I'll talk to you guys tomorrow. Remember, tomorrow is the exam. Be prepared. It's the last exam of the trimester. Have a good one, guys.